How about you just give over that day, and then you won't have to do it.
When you have a geometry problem, if it's not immediately obvious, I would draw a picture. Okay, so strategy number 1. Again, sometimes you can read it and it's like, oh, well, duh. But I don't know that this one's that way. Maybe it is. Maybe you just got lucky.
I didn't get lucky. I read it and it clearly, because they're similar, so they would be the same.
Well, not necessarily. Because you have to make sure you're comparing, like, did you notice that one was flipped over?
Yeah.
So you have to make sure you're comparing the same.
Well, I just looked at the number right there, and then I looked at it.
I know, but again, like, if you're comparing different angles, then you got to make sure that your ratio is set up correctly. Okay? In other words, don't just pick it because it seems obvious. Think through it. Like, can you explain why you picked B?
Why I picked B because it said.
In a geometric way.
I cannot do that.
Yeah, so it was basically an educated guess. Maybe not even, it might have just been a guess because of reading letters, right? And seeing that there was the same choice.
Well, I kind of just looked at the two numbers.
See what I mean?
Front.
Like, it's not even math. You're just doing, like, it looks the same.
Hey, they said they were similar.
Okay, but what does similar mean in math?
About the same.
No. What does similar mean in math? What? No? The angles are the same, meaning the same measure. So we could do some notation. This is review now. You wouldn't do this on your test, but those two are congruent, these two are congruent, and these three, or this one is congruent. Okay? That is one of the definitions of similar figures. Okay, what's the other one? Side being congruent would be congruent figures. We talk about this. So the sides are proportional, remember? So again, this has nothing to do with the problem, what I'm about to write, but it's good review. So if this is 5 and this is 10 and this is 12 and this is x, what is x? So it has, if these are similar, since 10 is double 5, x has to be double 12, right? And that would make the side lengths proportional, which means they keep that similar relationship. Okay? Now, that was a review. For us to be talking about sine, what kind of triangles do these have to be?
Right triangles.
Yeah, so we need to make sure, just to keep this at least consistent with our understanding of sine, cosine, tangent, we need to make sure they're right triangles. Okay? And then it says sine of f is 308 over 317. So where does the 317 have to go? Yeah, right? Now we need to understand that 317 is the hypotenuse. Otherwise, this is not a sine ratio. And if I stick f here, where does the 308 have to go? Opposite of f. Okay? So 308. And then it says FGH. So FGH, something like that. Okay? Remember, the letters in the name tell you what corresponds. So what corresponds to G in the other triangle? K does. It's in the middle of the letters. So K would go down here where G was in the first figure. What goes here? And then L. Okay? What, scroll this a little bit. Okay? If sine of f is 308 over 317, what is the value of sine of j? J.
Oh, yeah, you put 2K
I was like,
down.
you put 2Ks.
I was like, where's J? J. I was confused. Anyway, I was talking too much. Okay, so what is the value of sine of j? Well, do we know any lengths in this? No.
Angles are similar.
But what do we know about similar figures?
What'd you do? 5.
The sides are proportional, not equal. So what of these has the same value as the sign of F?
B.
So it is B. But now you know why. Okay? And I don't, like, you're setting a bad example, Emma. Is it bad to guess on SAT?
It's the last resort.
Yeah.
Okay, so my question is, it's dependent on the scenario. Do not leave a question blank because you don't get points for that. So if you guess, at least you have a chance of getting it right. Okay? So don't leave problems blank, number 1. But number 2, save guessing till the end if you're running short on time. And don't just guess because you want to skip it. Right? Like, oh, I don't feel like doing that. Guess. And I know a lot of people do that, and it's not a good strategy. Okay. Another way you could have done this faster, of course, I mean, we talked through all the review, but you can see F and J are corresponding angles. Do you remember that phrase, corresponding angles or corresponding sides? Because they're both the first letter. And then as soon as you you read similar, you know the value of sign has to have the same ratio. Otherwise it's not proportional. So it seemed familiar? I'm trying to remember when we did similar. I think it was January, probably. So it's been a little while. Alright, look at number 17. Take a look at that one. It has a lot of reading, doesn't it?
Yeah.
Okay, how long do you have for each question, roughly? Like if you average it out.
So there's 25 minutes to the whole test, I think.
No.
I don't know, that's what I keep saying.
Oh. Well, I think it's about a minute and... It's like a minute and a half, or just under a minute and a half, per question if you averaged it out.
Yeah, 'cause there's like 36 minutes and then there's like 20 something questions.
Yeah, but, well,
Like,
overall,
it's the same as the
yeah,
practice.
yes, it is.
Okay, so yeah.
So it's 70 minutes total for math, and I think there's 54 questions or something like
Yeah.
that. Or 44. It's 44 questions. So, anyway, I'm going to give you a minute and a half. Okay? Ready, set, go. All right, do 1, 2, 3, or 4 for A, B, C, and D. Just vote what you got. 2, 2, 1, 2, 2, 2, 2, 3. Well, the most common was number 2. Are you guys familiar with a dot plot?
Yes.
What does it show?
The number of something.
Yeah, kind of like a histogram, right?
I think that's
Sort of.
like probably the easiest math ever.
Oh, good. Okay.
Yeah.
So, glue sticks being brought for 2 classes, and then it says which statement, all that compares the. Is it important to read through every word of this?
Yes.
Sometimes, and then sometimes not, right? I probably would start, so if it was me and I'm a slow test taker, so I have to do strategies to save some time, I would probably start with this, or start here, like start at the question. Which statement best compares the standard deviations of glue sticks brought in by each student, okay? Or for the 2 classes. Do you guys know what standard deviation is? And here's where you're, like, we never get to statistics in math classes.
Like the average number of each thing. Well,
Each plot?
just,
Oh, like the average value?
yeah.
Oh, it's not, actually. Unfortunately. Okay, so everybody hear this. You'll hear a standard deviation, like, throughout your life. If you ever read, like, if you read a magazine, it has some kind of study in there, or even maybe a newspaper article. Basically what it is how far away from the average is a typical, let's say it this way. let's say our average height in here is 5'6", 5 feet 6 inches. Okay? I don't know what it is, I'm just guessing. So the standard deviation would break it down into the percentage of us that are within certain distance from that height. So if you're, maybe the standard deviation is like 2 inches, and we fit into 68% of us is 2 inches away, 96% 4 inches away, and it's a whole thing. Like if I asked you to calculate standard deviation by hand, you would probably throw something at me, because it's a lot of work. Okay? But look at the shape of the data. What do you notice first?
It's the same.
It's the same. So will the standard deviations be different?
No.
It shouldn't be, right? It's the same data set.
Yeah.
Okay? So what did you guys say you picked B
Yeah.
is equal, yeah, so it's the same. What would make the standard deviation change?
If one had more than the other. on
More
some-
data?
Yeah.
Not necessarily. If the relationship between the amounts of data was the same, it would actually still have the same standard deviation. So what else could change it? So thinking to our heights, I said it's a certain percentage of us that fall within a certain distance from the average height. So what would skew that off?
Something like 5'10".
Okay. Well, but I am. You're saying I'm going to throw things off?
Yeah.
What if someone came in here who was 6'8"? What would that do?
I don't know.
It would start to change our number, right? Like
Yeah.
they're way taller than the rest of us. Or like if somebody who, like a kid came in and was like 3 feet tall or something. Okay? Alright. I'll read you this. This is short but interesting. Algebra. So you get 44 questions. Algebra is 13 to 15 of those. So just under half.
I can't do it for a minute and a half.
Problem solving and data analysis. That's what this is. It's 5 to 7. Geometry and trig, 5 to 7. And then the last section is advanced math, is 13 to 15 questions. So it's a lot. Advanced math is like algebra 2 concepts, is what they're considering. Everybody listen, this is important so you understand how this test works. Did you notice you had modules? So module 1 is half of the questions and everybody gets the same module 1. From there, the test automatically scales and sends you on an upper tier versus a lower tier. So the upper is like harder and the bottom is easier. How do you know you're on which one which one you're on now? You don't. Yeah. It won't tell you, oh, you did good on the first section, so you get the harder tier. It won't say that. So here's the thing. If you feel like you're doing a bunch of easy questions, don't worry. That doesn't mean that you can't get a good score. Okay? You still can. If you feel like you're doing really hard ones, you can still get a good score, even if you're not sure if you're doing them correctly. So just do your best every time, right? Every question. I want to show you this one. We're not going to do it right now, but that's not it. This is a geometry one. Does it look like something we've seen before? Okay. So we'll come back to it another day to finish, but let's review a few things just since we're kind of in review mode for the moment. What can you tell me about things that we could add to the picture? Now, this is a frustrating thing to me about taking tests on computers is you wouldn't have that picture to write on. So you have to like draw it real quick and do your best to make sure it's accurate.
123 could go on the other side.
And what's the other side?
I could not see that. Where G is, the angle, not G, but going on
G?
it. On top right.
Here?
Yeah.
You cannot go there. Why? For this to go there,
Is it slightly like moved a little bit from?
well, and even if even if these unnamed lines were parallel, it still couldn't go there because those would then be same side exterior, which are not congruent. It would be like 123 going here. That's not okay, right? But we can put 123 in a number of different places, like where? Because you remember parallel line notation is a arrow, or perhaps if it's several sets, 2 arrows, 3 arrows, right? Remember that? Okay. Where else can 123 go? Where is that? Here? Here? Okay, remember corresponding angles? If I took this line and slid it up there, it would perfectly match the other 123. So it can go there. Where else? Let's just talk about all the places we can copy that angle.
Lost Brothers, where you see the 81 on top of the I think.
Here?
Yeah, no, that's yeah.
Not necessarily. But we can put 123 there. For 2 reasons. What kind of angles are these 2 that I'm pointing at? Alternate interior. Good job. And then what kind of angles are these 2? Those 2 are vertical. These 2 are corresponding. Yeah, good. Now, I think for now, what I want you to take away is any geometry problem, do not assume things, right? That's a temptation when we have a figure, especially this one. Like I agree with ammo. Those kind of look like they could be congruent. And so figures can tempt you to think that. Don't fall for that trap, right? We have to know things in order to mark things. So it's okay to say that whole angle is 123, but don't split it in half. Okay, where else can the 116 go? Okay, it could go here, corresponding. Vertical. Where else? How about here to there? What's that called again? Like this whole thing? Alternate interior. Good. How about here? How do we find either that angle or that angle? Linear pair, which is what? Like what does that mean? Good. So they have to add up to 180. So this would be 64 and 57. And then we could copy those to different places, right? Okay? Alright. Do you remember overlapping triangles? So we have that one and that one. And those were kind of hard sometimes. We had to... Well, when we did it, I think we were looking at like congruence and proving congruence and similarity and stuff. So this is not that kind of a problem, but it's still got overlapping angles. Okay, so we'll come back to that. Unless you want to, are you good with, you want to draw it and try to work through it? I'm seeing yeses and no's. We're on it. Let's just do it. Go ahead and draw it. I'll let you continue the... So that again, we don't want to split things in half. It's tempting, right? Especially when you get stuck. So here's where I actually did it and then got stuck because I should have read the question a little closer. And here's a frustrating thing about SAT. What does the question want us to find? X plus y. And sometimes that means you need x and you need y and then you add them. But in this case, it means we just need the sum. So we will never know what x and y are, which is annoying, but we'll know what their sum is, okay? So here's how that works. Do you guys agree that, like we talked through and Braden just said again, that this whole thing is 64? So this angle is 64 minus y. In other words, take y away from 64. We're good on that? Okay? Down here, we're going to do the same thing, only with the x. So just this angle is what? Can you give me an expression for that? 57 minus x. So we just take the x off. Okay? Now, if we look at this triangle, could we write an expression that has those in there? What would it say? Actually, you know what? I'm going to leave the parentheses off. Okay, plus 64 minus y.
Plus 81 equals 360. Wait, no,
180, yep, in that triangle. Good. Okay, 57 plus 64 is 121. Plus 81 is 202. So then we get this. 202. Okay, what would you do next?
Subtract.
Yeah, I might as well get rid of the 202, right? Okay, we're so close. This is where I stopped because I was like, I want to know x and y. Well, you can't find x and y with just one equation. But it doesn't matter because we're only trying to find the sum. So if we change the sign of everything, which is the same as dividing by -1, we will get x plus y equals 22. And that's what we're looking for. And again, it bugs me. This is why these tests can be hard for people. Because I want to know what x and y are. But we didn't actually be asked for that. So what do you think? She did this. You gave a big sigh. But it's doable, right? If you just play around with all the stuff you know, like you guys got all these 99s and 116s put in the right places and 64. And then you have to be that, like do that kind of, what's the word? Creative algebra, kind of. And read carefully. So this would probably be that second module top tier problem, the upper level. But you guys can do it. Any questions on it? Okay. Shall we go back to some circle stuff? Or do you want to do another one of these?
I think we should play it.
Well, why not? We'll play Uno next week after the test is over.
We should play
Yeah, like another, let's do another one of these kind, okay? Remember all of that was supposed to be done in an average of 1.5 minutes. So here's the strategy is the ones that are like, what's the slope? And it's in slope form. It takes 10 seconds. You can bank all that time for these harder ones, right, that take a while. All right, let's look. These are good review problems and prep problems because it's forcing us to persist through hard things, right? Here's the review part. Scoot that over a little. So obviously this one has an absolute value in there, so you really are kind of stuck if you forget how to solve those things. Okay, so let me remind you. Well, first of all, you I think did it in Algebra 1. Does it sound familiar?
Probably.
Well, okay. Let's see if you remember. Let's do a really easy one. just to review concept. What does absolute value mean? Okay. So it means how far is it, or distance from 0. Okay? So I want to draw a number line. And for this one, we're going to say 0 is there. And this is saying the distance x is from 0 is 10. How far is x from 0 again? Okay, so what value or values could it be? Could x be at? Yeah, so look at this. This is what's weird about absolute value. It could be 10. Do you agree that that 10 is 10 from 0? But it also could be negative 10, because it's also 10 from 0. So when you solve an absolute value equation, like this is the very most basic kind, you have to account for both the negative and the positive case. Okay? So if we were solving this, it would look like this. Positive case, and it doesn't matter which one you do first. You just drop the absolute value and set it equal to 10. The negative case, you drop the absolute value and set it equal to the opposite sign as the original. Okay? Does this ring a bell at all?
No.
Okay. So let me show you like the next step, next level of example. What if it was absolute value of 2x plus 10 equals, I don't know, 20. Whatever. Okay? So what did you just learn from this? You have to separate it out into the positive version of the right side and the negative version of the right side. Okay, so we're going to do positive, drop the absolute value, set it equal to positive 20, and then drop the absolute value and set it equal to what? Negative 20. Because that would be like saying these two are 20, and we have two ways of getting there. Okay? Now we just solved both of these little dinky equations. What does this left one tell us? Like, how do we solve it? Okay, we get 2x equals 10 and x equals 5. Okay, now we solve that one. First step, minus 10. Yep. Okay, this time we get negative 30.
Divide should be 15. Negative 15.
Okay, so you see how it gives us two answers, right? Alright, so that's kind of the idea behind solving an absolute value equation. Take whatever you have and on the right side, make a positive and a negative version, and just ignore the absolute value on the other side. Okay? Everybody get that? So over here on this one, what is the value of k when this only has one solution instead of two? So we still have to do all that same thing, but I'll show you what to do at the end to account for one solution. But first, how do we get rid of this 1/4? Because it would certainly be easier if we didn't have that. Remember? Well, what is it doing right there? What's going on in there? Yeah, so how do we undo multiplication? Well, okay. We undo multiplication by division, so that would mean divide by 1/4, right? That's what you guys are saying. I think it's easier to think of it though as this is dividing by 4 because it's on the bottom. So how do you undo dividing by 4? Times 4. Do you remember how we said when we learned about fractions earlier on this year, if you have a fraction you can just multiply by the denominator? Okay. So now we just have to be sure to multiply the 1/4, the 30, and the 2k. All those things. So this goes away because that's why we did this whole process. What's 4 times negative 30? Whoops, I put equals in the bottom. Yep. And remember, you get to use your calculator on the whole test. So use it, use it, use it. All that you can. Okay. This is basically the same situation as what we just talked about. We want to get this by itself. So what would your first step be?
Add.
Okay. And then we'll do absolute value of x minus 4 equals 8k plus 120. Okay? Now it's ready to take the positive and the negative version of that side, just like we did over there. Okay? So we're going to just drop the absolute value. And you don't have to label, but I'm just doing it so we know where stuff's coming from. X minus 4 equals 8k plus 120. That's, you just take what's there and copy it down. That's the positive version. Okay, the negative version, you could also use the word opposite for negative. Sometimes that helps. So we drop the absolute value, and then we take the opposite of the right side. Just like we did down there. And again, it would be like the positive side and the negative side are the same distance away, okay? Okay, now we just, I know we have two variables in here, but that's okay. Let's get x by itself. Add 4. So we'll get x equals 8k plus 124. Okay, over there. Sure, we can, but we have to be careful with sign here, right? So this is negative 8k, and this is negative 120 plus 4, which is what? Yeah. Okay. All right. So this is equivalent to our two solutions before. Does everybody see that? We just have this k value, so we don't have an actual number. But it's the same thing. We have a positive solution and the other one. Okay? So the problem then asks, what is the value of k so that these are the same? So that it only has one solution. So what would you do with these two things? If it wants them to have one solution, that means these have to be the same one solution. So what does that mean to do in that?
Would you have to combine the equations?
Yeah, somewhat. You just set them equal because these are both x now, right? So if we say x equals x, we can just set these two pieces equal to each other. Because x and x are the same thing. It represents the same thing. So we can just set them equal. Okay, now we just have like this usual regular thing. So we can add 8k and get 16k and subtract 124. And I think that's 240 negative. Will you check? 2, I don't need 2 actually. 6 and 4 is 10. 2 and 2 is 41. And then divide by 16. I don't know what that's going to be. That's definitely a level 2 or whatever they call that higher level, right? If you happen to go back and look, remember that this whole section over here was just review. We didn't have to do that stuff. But it is still a pretty long problem, right? How do you feel about that? Keep in mind, Bailey asked for this one.
Alright, guys.
It was her idea. Okay, we'll do some more of these. I don't know if you can read this, but 10 hardest.
I was looking at that. I was like, wow.
So
Hard.
this is
I
gonna.
can't even handle one.
This is reviewing the 10 hardest kinds of problems you'll see on SAT. So we'll take a couple a day, okay? And then we can be encouraged when we go back to ones like I don't know. Like, pick one. Like this. For the linear function h, b is a constant and h of 0 is 45. What's the value of b? You can be encouraged when you get to one like this and it's like 10 seconds.
5.
Or not. Alright, read it again, because this one should be a 10-second problem.
Oh, I get it.
I know.
Okay.
It doesn't like change it.
Do a different color. No, you need, don't say stuff like that. Do you see how x became 0? That's what this notation means. Whatever is in the parentheses is what you plug in for x. So if I plug 0 in for x, what becomes b? Look, if I plug 0 here for x, and it's supposed to equal h of 0 is 45, then what does b have to be? Has to be 45. So this is a no calculation problem. It's a notation problem, right? It's knowing, this is called function notation. It's knowing that when they change that from x to 0, it means plug in 0 for x. And then you can just set the whole thing equal. Okay, it's like finding the y-intercept. Remember that? Here, let's do another quick one. If I said f of x is x squared plus 2x plus 10, and I said what is f of 2, what does that mean to do? Plug 2 in for x. So now it's going to look like this. 2 is x. So 2 squared is 4, plus 2 times 2 is 4, so we're at 4 plus 4, plus 10.
18.
Okay, so f of 2 is 18. That's what this was. There's a lot to learn, isn't there? A lot to know.
Yeah.
It's more important.
Are we really practicing if we're not doing and we're just window shopping?
No, we already did some.
Alright, we will come back to this one. Here's the next one.
Oh.
Nobody.
Who did this?
So, would you time?
Huh? No, you
I
need to
feel
come
like
up.
you would multiply it.
Okay, so I guess we could break this down a little.
Who did this?
What's an integer?
I forgot.
Oh.
I forgot.
It's a positive or negative whole number.
Oh, I look.
That's all. So negative 1, 10, negative 20, 30. In other words, k is not going to be a fraction, right? Or a decimal. Okay.
I don't even know where to start on this one.
I mean, so she said she doesn't know where to start, but do you know how to add fraction? Well, in this case, subtract fraction.
Before even that, there's just so many steps.
Well, the first step
Because
is
you got
actually the
letters
same.
and numbers.
Like, what if it was 1/2 minus 1/6? What would you do?
Be like 1/4.
Are you serious?
What about the top ones? 1 and 1.
Well, what if it's 7? Like, does it matter? In terms of what you would do, it doesn't matter, right? It changes your result, but how do you add or subtract fractions? Yeah, good. Common denominator. So, what's a common denominator for these two?
2.
2.
Common denominator means they both have to go into it,
Yeah.
not the denominator into them. So what do 2 and 6 both go into?
12.
12, yeah, but 6 is better. But 12 works. Right? In this case, it doesn't matter, actually, which one you pick. So what do you have to do to make this one be... Do you want to do 12 or 6?
6.
Okay. What do you have to do to make this one be 6? By 3 over 3. Right? Because otherwise you change the value. So this would be 3/6 and then minus 7/6. And now, do we do anything with the denominator?
No.
Okay. So what does this become? Negative 4/6. Right? Okay. Same strategy. I wish I had done that. Let's just erase. Ready? I'm not going to worry about the right side for now. But do you see how these could be thought of as two different numbers? So what does this side need? A 63. What does this side need? Well, it's this guy's denominator, right? So it just needs a k. Right? So this becomes these 63 times 1 is 63. 63 times k is 63k. That's that for now. Okay? Other side. Minus, what does this become? Yeah, xk, or I'm going to write it as kx, but it's either one. And then 63k. Okay? And then what? We don't do anything with the denominator. What do we do with the numerator? Yeah, you just write it as subtraction. We can't really do anything with it.
It's just there.
Yeah. Okay, and then the other side, 5 over kx. Okay, anyway, so the left side looks better, I think. To me it does. Okay, and then you guys, we have done a lot with proportions this year, right? Just what do we do to solve them? We can butterfly them. Another strategy that you can do with these is multiply to get the same denominator on both sides of the equation and then just set the numerators equal. That's another thing. That's kind of what butterfly is. This says if the equation has more than one solution, what is the greatest possible value of k? So let's do our cross multiplication. Do you want to just do all this? Are we doing it?
Might as well.
Now that we're in it?
Probably
I mean, we were window shopping and now we went in. And yeah. Somebody found a dress they like. Ammo.
I'll wear one to school. I will.
I bet you would.
Yeah, I was thinking about my prom night, dressing up like a girl doing makeup with a wig.
Everybody will have nightmares. Okay, so all we did was the cross multiplying, right? And now we can distribute 63kx, kx. And then what is kx times negative kx? What was it? Oh, well, that would be if we added, but since we're multiplying, k squared x squared, and then what is this? 315?
Yeah.
Okay. So now we see a quadratic. So what do we do with that? Well, we probably should kind of get stuff together so it looks like a quadratic, right? So I would probably write it like, I'm going to move that over and this over so things are more positive. Like, I don't like this to be negative. That's confusing. So k squared x squared minus 63kx plus 315k. Okay. Good? This should look familiar. This is just a quadratic. If we ignored all these k's, we've done these lots this year. X squared minus 63 plus 15. Doesn't that 315? That looks familiar, right? Okay. So we just have all these dumb k's floating around. So what does it mean? Like now that we know what we're looking at, you guys know what the shape of a I just about said it, but of a quadratic is? What's the shape of a quadratic graph? Remember, like the basic one is this. That is y equals x squared. Okay? And it goes down and touches right at the origin, right here. Okay, so what is, this is deep. First, I mean, just to get to this point is a lot, and then you got to understand what the question's asking. Does anybody even understand what it means by this? More than one solution. Do we know what that means? Okay, but what's a solution when you're talking about quadratic graphs? Man, what are you going to do on this when you get to the test, for real?
Yes.
This would be one that you would save till the end, right? Maybe plug something in a graph and see if that helps, like on Desmos on your screen.
Yeah.
And try to just make an educated test. But this isn't one you're going to try to do and waste like 15 minutes, right? For sure. I'll finish. How much time do we have?
Yeah,
4
like 4
minutes.
minutes.
Alright, you better be fast. Guys, in solutions for quadratics, don't pick up and you won't listen.
I'm not packed up. I gotta calculate.
Alright, that's where it's crossing the x-axis. It's x-intercepts. Okay, so how many solutions does this one have?
2.
Right now it just has the 1 right there. Okay?
Okay.
Okay, if this is shifted up, like what if it was up here? How many solutions does it have? Has none. You'll learn about imaginary numbers when you have that.
Imagine
Okay? But what if this was shifted down and it came like that?
2.
Yeah, 2 of them.
Now it would have 2 solutions. Okay? So listen to our question. What is the greatest possible value of k to have more than one solution? In other words, how far can we shift this thing up before it has only 1 instead of 2 solutions? Make sense?
Yes.
Okay. So now you have to understand how to figure out what k is that moves that up or down. Okay? And to do that, we need to figure out how to rewrite this in a way that shifts this, that we can see a shift up or down. And that will take a little bit more time. So we'll have to stop there. I know you're so sad.
So